review on solubility curves and how to read them. So let's go through this step by step. All right, so question 1 says, I want to know how many grams of ammonium chloride can be dissolved at 80 degrees Celsius. All right, first thing we want to do is we want to label the 80 degrees Celsius as either our X or our Y coordinate on our graph. So if we remember from math, this axis is our Y, and this axis down here is our X. All right, so temperature is the X and grams, all right, is the Y. So I'm going to go back up here and I'm going to label, okay? Question, all right. So like I said, I'm looking for grams. So grams is the Y coordinate that I'm looking for. Can be dissolved at 80 degrees Celsius. Temperature, again, was our X. So they gave us the X coordinate and we are now looking for the Y. The first thing I want you to do is find ammonium chloride on the graph below. So here's our graph. Looking for NH4Cl, and it is right here. And I'm going to trace it so that it's easier for us to see. All right, so it's got a little bit of curve in there. First thing I'm going to do is I'm going to find 80 degrees Celsius. All right, so here's my 80 degrees Celsius right here. I'm going to draw a straight line all the way until I hit the line that they asked us about. All right, so there it is. So this is our X. Now I want to know what Y coordinate over here corresponds to this X. So what you're going to do is you're going to take your ruler. If you have a ruler, if not, it's still like a guesstimate, right? It's okay. And I am going to draw a straight line all the way over, right? And so it hits right about here. And I'm guessing it's not exactly halfway between 60 and 70. It's a little bit less than half. So I'm going to say that I hit that Y-axis at 63 grams. Okay, so when you're looking for the Y and they give you the X, this is all you're doing. You're going to go up until you touch the line that they're asking you for on the X axis, right? And then you're just going to go over to that Y axis and see where you hit. So that was question 1. Let's go on to question 2. Question 2 asks me, if 80 grams of KNO3, potassium nitrate, 80 grams, remember grams was our Y, so I'm going to label this Y, are dissolved in 100 grams of water. Now here's what I want you to notice. You see over here, it says grams of solute per 100 grams of water, right? That means that this 100 grams of water right here in our question, we don't need it. It's just part of the Y-axis, all right? So I'm going to scratch that out because I don't want to accidentally use it. So that 100 grams of water is never important. And I have 50 degrees Celsius. Again, temperature is your X coordinate. Is the solution unsaturated, saturated, or supersaturated, right? So this time they gave me an X and they gave me a Y. The first thing you always want to do is find the line that they're talking about. This time it's KNO3, and we're going to trace it. So KNO3 is right here. The line is always below what they show you. So I'm going to go ahead and I'm going to trace this line for us. Okay. Now, if they give you both an X and a Y coordinate, and I have a graph, what you're going to need to do is you want to plot that point. So I'm going to plot the point on the graph. It says 50 degrees Celsius, so here's 50, and I have 80 grams, so I go up till 80 grams, which is right here, and I plot that point, right? So I'm looking for unsaturated, saturated, or supersaturated. So as a reminder, saturated is on the line, okay? Unsaturated, okay, is under, right, the line. And then super saturated, I'm going to abbreviate it because I'm running out of space, means that it is above the line. So I want to know, where does that dot fall compared to the line? Is the dot on, under, or above? Okay. So I'm going to go back to my graph over here. And if you notice, my dot or my point is on the line. And we said if it's on the line that it is saturated. So this is a saturated solution. All right, let's move on to our next question. Our next question says, at what temperature, so temperature, we want to label it as X or Y. Again, temperature will always be our X. Will approximately 30 grams of potassium chloride, or KCl, grams is always our Y, dissolve in 100 grams of water. Remember, we do not need the 100 grams of water. All right, so this one is similar to number one. The difference is this time they gave me the Y and I'm looking for the X, but we're going to approach it in the same way. First things first, let's find KCl and let's trace that line. All right, here's KCl, so the line is below it, right? So I'm going to trace it real quick. Okay. So again, let's use the information they gave us. They gave me 30 grams, so I'm going to find 30 grams, and I'm going to go all the way over until I touch the line that I have. So 30 grams is right here. Let's go over until we touch the line, which is right there. And now to find the temperature, or that X coordinate, we're going to draw our line straight down. And it hits the X axis at 10. So it would be 10 degrees Celsius. One more question for us as far as our examples go. I want to know if 20 grams of NH3 or ammonia, grams again is always the Y, we'll label it, are dissolved in 100 grams of water. We never need the 100 grams of water at 80 degrees Celsius. That's my temperature, so that's going to be my X. Is the solution unsaturated, saturated, or supersaturated? So again, when I plot the point of 20 grams and 80 degrees Celsius, am I going to be on the line, under the line, or above the line? So again, find our line for NH3 first. So here's NH3, so here's our line. So let me turn this to trace this. Okay. They give us a Y and an X coordinate, so we're going to plot that. So 80 degrees Celsius and 20 grams. So here's 80, I'm going to go up to 20 grams. Right? They meet right here. So there's my point. So my point is above the line. So again, if it's above the line, then it is super saturated. And that's how we read solubility curves.